Hello everyone, how are you? I am Miss Ala Atif and this is a new session from the revision sessions of the first term. This session is for grade 6. So this is the first part in the revision and we are going to revise on unit 1 and 2. So are you ready? Let's start. Can you remember unit 1? It includes 4 lessons. The first lesson was talking about long division. Let's remember together what is the long division and how can we solve it. In the division, for example, if I wrote 25 divided by 5, it will be, of course, 5. Then here, this 25 is called what? This is the dividend divided by the divisor, and the answer of the division is called quotient. So again, remember with me, this is dividend, divisor, and quotient. And here we don't have any remainder. The remainder is 0. But if we have 27 divided by 5, the quotient will be also 5. But here we are going to find that we have a remainder which is 2. So in the division, sometimes we get remainder 0, or we can get the remainder equal 2, 3, 4, or any other number. But how can we solve the division for the long numbers or with the big numbers? This what we learned together in the long division. Can you remember? The standard algorithm in division. We draw our division sign and we put the dividend inside and the divisor outside, then start to write the timetable of the divisor. So here we have 1845 divided by 15. So we must go and write timetable 15 here like this draft. 15 times 1 equal 15, 15 times 2 equal 30, and so on. After that, we are going to start to look at digit by digit. So here, can we make 1 divided by 15? Of course not, it's smaller than 15. So I am going to take the whole 18. Now 18 divided by 15. To know what is the quotient, we are going to search where is the 18. We can't find it, but we can find that it's in between 15 and 30. Here is the 18. So we are going to go to the upper one, the smaller one here. 1 will be up and take this 15 down and make subtraction. 8 minus 5 equals 3. 1 minus 1 is 0. Now drop down 4. You have 34. So we are going to search again. Where is the 34? Can you see it? Yes, it's here between 30 and 45. So we are going, of course, to look at the lower one, which is the smaller. So we are not going to take 45, we're going to take 30. So put 2 up in the quotient and put 30 below 34 and make subtraction. 4 minus 0 equals 4, 3 minus 3 equals 0. Now we have 4 and we are going to drop 1 number, which is here 5. So drop down 5, now it's 45. Can you find 45? Yes, it's here. It means that we will put the 3 up and 45 down, so 0, 0 is the subtraction result. It means that we don't have any remainder. The remainder is 0, but the quotient becomes 123. Let's solve another example together. Again, what is the first step? Solve with me step by step. We are going to put our long division sign. Put the dividend inside. It's 1,515. And where is the divisor will be? Yes, outside. Then go and make your draft to write the timetable. We are going to write which timetable? Sure, timetable 15. So 15 times 1 equals 15. 15 times 2 equals 30. 15 times 3 equals 45. And we can stop here. If we need to complete the timetable, we are going to complete after that. Now let's look digit by digit. Can you take the 1? 1 is smaller than 15, so I'm going to take with it another digit. So here we have 15. Where is it? Can you find 15? Yes, it's here. It means that we are going to put the 1 up in the quotient place. So here is 1 and put down 15. Then make subtraction. 15 minus 15 equals 0. Now we need to drop down a number. So let's drop down 1. Can you make 1 divided by 15? No, it's smaller. That's why we are going to put up a 0 because we need to drop down another 1. So we can't drop 2 digits unless we put 0 here. If you drop one number and you didn't divide them because it's still small, you put up 0, then drop down the second. Now we have 15. Can you find it? Yes, it's also 1. So put here 1 and put 15 down. Make subtraction. It will be 0, 0. It means that the quotient equal 101 and the remainder is 0. Can you remember when we have a story problem? How can we know that this story problem means division? We have some keywords that help us in understanding the meaning and understand that this story or word problem related to division. Like what? Like these words, distribute, share, when he say equally, or put in equal groups, or fairly, or when he say break down, cut into, or split. All these words can help me to understand the story problem or the word problem and understand that this is a division story problem. This was a quick revision on lesson 1. After that, can you remember lesson 2? Prime and composite numbers. What are the prime numbers? We said that the prime means the number when we factorize them, we are going to find they have only 2 factors, 1 in itself. Like what? Like number 2, 3, 5, 7, and so on. What about the composite? Composite numbers are the numbers that have more than 2 factors. So any number has more than 2 factors is called composite number. What about number 1? It's not a prime and also it's not a composite. So 1 is neither prime nor composite because it has only 1 factor. After remembering the prime and composite numbers, we want to get out the GCF, the greatest common factor, and the least common multiple. Let's try to solve them together. Here we have 18 and 24, and we want to get the GCF and the LCF. Step number 1, we are going to make the prime factorization. 18, it exists in which timetable? We can say 2 times 9, yes. Is the 2 prime? Yes, so we are going to leave it. But 9 is not a prime, so I am going to factorize it again. 9 is 3 times 3. What about 24? It's in table 3, so I can say 3 times 8. The 3 is prime number, so I'm going to leave it like that. But the 8 is not a prime, so factorize it. It's 2 times 4. Now I have 2 prime, but 4, we still can factorize it, so we can make it into 2 times 2. After that, we are going to put them below each other. L18 equals what? Put only the prime number that you reached. So here you found out that the prime factorization of 18 is 2 times 3 times 3. So we are going to put 2 times 3 times 3. Then below the 18, we have the second number, which is 24. What is the prime factorization of 24? Here we have 3, 2. Can we take 4? No, it's 2 and another 2. And don't forget, we must put the same numbers or the similar below each other. So below the 2, we should put also 2. So here we have 2 times 3. Can we put 3? No, we don't have any other 3. So go far and write 2 times 2. Now, what is the GCF? GCF is the number which exists in both of them. So put your line and then take each 2 together as a 1. So here the GCF will be, can you make it? Yes, we have here 2. So we will take it as only 1, 2 because they exist above each other. Like that. And here we have 3. So the GCF equals 2 times 3, which will give you 6. So this is the greatest common factor. What about the least common multiple? We are going to drop down all the numbers. So we have LCM equals 2 times 3 times 3 times 2 times 2. Can you solve it? 2 times 3 equal 6. And 3 times 2 is 6. So we have 6 times 6 equal 36. After that, make 36 times 2. Can you remember the multiplication? You can make it with the ones. Starting from the ones, 2 times 6 equal 12. Put 2 and carry up 1. Then 2 times 3, 6, and you have 1, so it's 7. So this is the LCM. This was the prime factorization, or how can I get the GCF and the LCM? After making them, how can we draw the Venn diagram for them? Venn diagram means that we have two circles, a circle for each number, and there is an intersection between them. So the first number was 18, so put here 18. The second number is 24. And in this intersection part, what we put? We put the GCF, or the common number that are here and here. So we have 2 times 3, or 2 and 3. So put in the middle 2 and 3. So this is the GCF. What about this part? This part means the number that exists only in 18. So what left on 18? 3. Yes, so we are going to put here only 3. And what about 24? We have 2 and another 2. So here's 2 and 2. So this is the Venn diagram for 18 and 24. Let's remember these notes together. What the meaning of relatively prime number? Relatively prime numbers are the numbers that not prime, but if I factorize them, I'm going to find that the GCF is 1. Or in other meaning, in the Venn diagram, I'm going to find that the intersection part is empty. Like what? Like this example, if I give you number 15 and 8, can you factorize them? I want from you to factorize them and draw the Venn diagram. Okay, so the 15 will be 3 times 5. The 8 will be 2 times 4. And the 4 will be factorized again into 2 times 2. Now, can you put them below each other? 15 equals 3 times 5. What about 8? Equal 2 times 2 times 2. So 2 can be below the 3, and I'm not going to put it below the 5. So go for and put 2 times 2 times 2. Now, what is the GCF? Again, we said the GCF of the greatest common factor mean the number that exists up and down. Here we don't have. So it means that the GCF is the number which is a factor for all numbers, which is 1. And if you want to draw the Venn diagram, you are going to find that we have 2 circles. The first one is for 15, and here is 8. And we are going to put what inside this part, the intersection part? It will be empty because we don't have any factor. So when you find this is empty, it means that the GCF equals 1, and it means that these two numbers are called relatively prime numbers. Of course, here in the 15, we are going to put its factors, 3 and 5. And here we find that it will be 2, 2, and 2. So again, what the meaning of relatively prime numbers? Two numbers has no common factors in between. What is the common factor of all numbers? Can you remember? Yes, sure, it's 1. And what is the common multiple of any numbers? We said multiple. If I ask you what are the multiples of 2, you're going to say timetable 2. So 0, 2, 4, 6, 8, and so on. If I ask you what is the multiples of 3, 0, 3, 6, 9, and so on. So in any timetable, we are going to start with 0. It means that the common multiple of any number is 0. So don't forget these notes. Writing expression. Can you remember if he gave me an example like that? If Mona has 20 oranges and 35 apples, what is the greatest number of bags can she prepare with no leftover? Write the expression which represents the total number of these bags. What we are going to make is to take the two numbers, factorize them, then get out the GCF. Then write the expression. Expression will be the greatest common factor, multiply the brackets, which includes what is left in the first number only, plus what are the factors of the second number only. So let's try to solve it together. Again, we have two numbers, which are 20 and 35. We need to factorize them. And you factorize 20, it will be 4 times 5. But the 4 will be factorized again into 2 times 2. What about 35? Yes, it's 7 times 5. Now we are going to put them below each other to get the GCF, or the greatest common factor. 20 equals 2 times 2 times 5. And the 35 equals, here can you put 2? No, we don't have 2 or 2. We will put the 5 below the 5, then put the 7. Can you see here? Where is the GCF? Yes, it's number 5 because it's exists here up and down. So the GCF here is 5. Now, after getting the greatest common factor, we need to put the expression. How can we put the expression? Again, we put the greatest common factor outside, which is 5. Open your brackets. Put the factors of the first number only, which is, here you have 2 times 2, so it will be 4. Plus, the second number has factors, which are 5, but this 5 is common, so we are not going to take it. What exists only in 35? It's 7. So put it here. So this is the expression. And what the meaning of this expression? It means that Mona can make 5 bags. Inside each bag, we have 4 oranges and 7 from the 35 apples. So we can distribute these fruits among 5 bags. Each bag will include 4 from the oranges and 7 from the apples. This is related to the distributive property. If we say that we have 3 outside, like the greatest common factor, and inside the brackets we have 5 plus 4, it means that we have what times what plus what times what. The distributive property means 3 will enter to each one of them. So here we have 3 times 5. It will be plus 3 will go to the second number, which is 3 times 4. About here, 14 plus 21 equal 7 times. Okay, we are going to think 7 times what? Give me the first number here, which is 14. Yes, sure, 7 times 2 equal 14. Then the 7 times what? Give me 21. It's 7 times 3. Okay, let's move to the second slide. Okay, how can we make adding fractions? In order to make addition for any two fractions or subtract them, we must have the same denominator. So if I have the same denominator, I'm going to solve it. But if I don't have the same denominator, like if I have 1 over 5 plus 3 over 5, 3/5. It's so easy because here the denominators are the same. So we are going to put the same denominator and only make addition for 1 plus 3. It will be 4. The problem is when we have two different denominators, like if I have 1 over 2 plus 3 over 5. How can we solve it? We need to get the same denominator. And how can we get it? Yes, with getting the LCM. And as we revise, we are going to get the LCM with the factorization of the two numbers, then solve it. So here, what is the LCM of 2 and 5? The 2 is a prime number, so it will be only 2 times 1. And the factorization of 5 only will be 5 times 1 because this is a prime number. It means that the LCM will be 10. So the new denominator will be 10. Now we are going to put instead of 2, we will put 10. Instead of 5, also we are going to put 10. But because we changed the denominator, can you remember what will happen to the numerator? Of course, it will change also. Okay, so here, the 2 becomes 10. It means that I made it times 5. 2 times 5 equal 10, so I'm going to make the same multiplication to the numerator. 1 times 5 will be 5. Here, how the 5 becomes 10? 5 times 2, so go to the numerator and make 2. So the 3 times 2 equals 6. Now we can put the same denominator, which is 10, and make addition for the numerator. 5 plus 6 will give you 11. And this equal 1 whole and 1 over 10. So we can convert the improper fraction into mixed number as we studied in our sessions. Let's move to Unit 2. Can you remember in Unit 2? We have something called rational numbers. Let's remember together the set of numbers. The first one, or the smallest set, is called counting. And we said counting means I can count the numbers. So it starts from 1, 1, 2, 3, 4, and so on. After it, we have the natural numbers. And natural means all the counting numbers, but we are going to add with them 0. Then we have the integers, and the integers includes all the positive numbers and the 0, but we also add for them the negative numbers. Like here, we have 0 and this positive part, 1, 2, 3, and we add the negative parts. So all of this is called the set of integers. The last set that we studied is the rational numbers. And what the meaning of the rational numbers? It includes the fractions, the decimals, and the percentage. Let's remember these notes together. What is the greatest non-positive integer? We said what the meaning of non-positive? Non-positive is any number that is not positive. And we have the numbers are divided into 3 parts. It may be positive or negative or 0, because the 0 is neither positive and nor negative. It's not positive and it's not negative. Now he is asking about non-positive. So it will be one of them, negative or 0. Where is the greatest one? Of course, the 0 is the greatest than any negative number. So the greatest non-positive integer is 0. Number 2, can you see? Here he asks you about the smallest non-negative integer. Again, non-negative means not a negative, so it may be 0 or it may be positive, which will be smaller than the others. Of course, 0 here will be smaller than any positive number. So the smallest non-negative integer is 0. Okay, what if he asks the smallest positive integer? The smallest positive. So I'm not going to choose the 0. I need positive, and the smallest positive, of course, is number 1. And what about the greatest negative integer? Okay, so I'm going to go to the negative numbers. Can you remember them? Here is the 0, then the negative will be on the left. -1, -2, and so on. Where is the greatest one of them? Yes, this is the greatest negative number, so it's -1. What is the smallest natural number? We said natural means the 0, 1, 2, 3, 4, and so on. So the smallest of them is 0. But if he say the smallest counting number, can I write 0? No, the counting starts from number 1. So don't forget, the smallest counting number is 1. Okay, if he asks me just after and just before. For example, he will give you a number like -2, and he asks you what comes just after -2, or he will say what is the number that comes next to -2. We are going to draw our number line to make it easier. Then put the number that he asked about. He asked about -2, so it means that here we have 0, -1, -2, -3. When he say after, just after, or next, it means that you are going to jump forward. But when he say before or just before, you are going to return back, jump backward. So what is just after -2? You're going to go to -2 and jump forward. So it will be -1. What is just before -2? You are going to go to -2 but jump backward. So it will be -3. Then remember with me the keywords that mean that we have a positive integer, and what are the keywords of the negative integers. The positive keywords, when you see the word above, for example, I'm saying that we are 300 above sea level, 300 meters above sea level. So it means that we are on positive or plus 300. The word deposit is positive. Gain, profit, high, increase. All these words are positive integers. Okay, the keyword that mean that we will have a negative integer. Below, the word withdraw, loss, and decrease. Again, some important remarks. Remember, the meaning of additive inverse, it's like the opposite of the number. So what is the opposite of 4? I'm going to put the same number, but I will make the opposite of the sign. So 4 here is positive. I'm going to put it as a negative. So the additive inverse of 4 is -4. What about -7? The additive inverse of it will be 7. And the additive inverse of 0 is 0 because we don't have a number called -0. What about the absolute value? Can you remember it? Yes, absolute value, like these two lines. And the absolute value means the distance, or it's used to describe the distance between any 2 points. So we said that the distance can be negative. It means that the absolute value eats the negative sign. So this negative will be eaten. So the absolute value of negative 3 will be 3. What about the absolute value of 5? 5 here has no negative, so it will be as it is. It's 5. So the answer of any absolute value must be positive number. We have 4 words: belong and its opposite, doesn't belong. We have subset and not subset. When we choose from belong and doesn't belong, and when we choose between subset and not subset, when he gave me here a one element, like a number, only one number, it means that you are going to choose belong or doesn't belong. But when he gave me at first a set of numbers, complete set, or a group of numbers, you will choose from subset and not subset. Like here, -3 belong or doesn't belong, or subset or not subset to the counting numbers. I'm going to think at first. I'm going to choose belong and doesn't belong, or subset and not subset. -3 is only one number, one element. So I'm going to choose from here, from belong and doesn't belong. Now, -3, can we say that this is a counting number? Of course not, because this is a negative. So we will choose doesn't belong to. And this is the sign of doesn't belong to. What about -4/2? Again, this is only one element, only one number. So we are not going to choose from subset or not subset. We are going to choose from belong and doesn't belong. Is this an integer? Integers means positive numbers or zero or negative numbers, but without being a fraction or decimal. At first, let's simplify it to see if it will be a fraction or not. Can you find 4 and 2 in any timetable? Yes, they are in timetable too. So we will make divided by 2 up and down. 4 divided 2 equal 2. And 2 divided 2 equals 1. And don't forget we have here a negative sign. And we said before that any number over 1 equal the same number. So -2 divided 1 will be -2. Now, can you tell me this is a fraction, or we can say that this is an integer? Yes, -2 is an integer, so it belongs. What about here? When he says set, so we are going to choose subset or not subset. Set of integers is subset from the counting numbers. Subset means it's a part, like here, this is a small part inside the counting. Can you remember our drawing? We have 4 circles inside each other. We have the counting, then the integers, natural at first, then integer, then rational. If the integers inside the counting, it's a small inside the counting, of course not, so we are going to write not subsets. So this is not subset. What about the second one? Set of counting number. The counting number here is subset to the rational. Is it a part inside the rational? Of course. So this is a subset, yes. Okay. Here, how can we represent the numbers on the number line? Can you remember? Let's draw our number line. 7 over 5 means what? At first, you are going to put your numbers 0, 1, 2, and we will be on the positive part because this number is positive. After that, you need to convert them into fractions with the same denominator. Here the denominator is 5, so make the 0. It will be 0 over 5. What about the 1? It will be 5 and make 1 times 5 equal 5. What about the 2? It will be also a fraction with the same denominator. Then the numerator will be 2 times 5 equal 10. Now, where is the 7? Here 5, so here is 6 over 5, here is 7. So this is our point. So you can point like that. This is 7 over 5. What if he gave me a negative number? It means that we will make the same idea, but we are going to draw on the left side of the 0. So here we have the number line. Start to put your numbers, but here we are going to put 0 here. Before the 0, we have -1 and -2 because our number is negative. Now let's convert all of them into, yes, fractions with 4 as a denominator. Let's convert them. The 0 will be, put here 4, then make 0 times 4, 0. Here put the same denominator, 4. Make 1 times 4 is 4, and don't forget the negative sign. Okay, what about the 2? Put the same denominator, 4, and don't forget 2 times 4 equal 8, but with the negative sign. Did you find -9? We haven't reached it yet. It means that we need to complete. After -2, we have -3. And convert it into a fraction with the denominator 4. Now 3 times 4 is 12. Don't forget the negative sign, it's -12. Now, where is the -9? Yes, it's after -8 over 4. Here we have -9. Okay, these 3 marks are so important, so remember them before your evaluation. There is no integer between any two consecutive integers. It means that the set of integers, which is an infinite set, but doesn't have the property of dynasty. Like if I give you number 1 and 2, can you find between them any other integers? Of course not. But you can find between them rational numbers. And rational numbers means you can find decimals or fractions. Like you can find 1.2, 1.3. You can find 1 point, for example, 222. You can find 1 and 1/2 mixed number like that. So you can find an infinite number of rational numbers, but you can't find any integer between these two consecutive integers. This was our first part in revision for grade 6. Thank you for watching and see you inshallah in the second part. Bye bye.